Good afternoon, everyone. I did not start anything here. I think we did not miss anything. Yeah. Will I start the class now, Nana? Yes. Okay. We will go here. Okay, no problem. Okay, remaining they may watch on YouTube, so can't deny them. Okay, right. Good afternoon, Nana. I think yesterday we discussed about some introduction related to the acceleration of a particle. Okay. In that again, we have two types. Yesterday we discussed. One is nothing but I explained with one example that increase in velocity, uniform increase and non-uniform increase. Okay, one is called as uniform acceleration, other is variable acceleration. Okay, non-uniform acceleration. So from the concept what we discussed yesterday, today I am going with the concept related to uniform acceleration. Okay, right. Oh, what is this? Uniform acceleration. Okay. This uniform acceleration actually you have in your 9th class now. And there you learned few equations of motion also. Okay. So before teaching them means reminding them, if we go through the problems, whether we recollect them or not. Okay, once we check now. Right? Suppose here I gave one example. Okay, that is example 1. Here I am saying that a body is started from rest. Okay, is started from rest and accelerated uniformly. This is a simple one. I think you can recollect. Uniformly, right? And here I am saying find nothing, Nana. This is the first thing I am saying here. You can see on the board. Just I am writing, not even explain. Okay. Find here. Find the velocity of the particle of the body after say some 2 seconds. Okay, given that nothing happened. Given that, okay, nothing I explained, just I'm giving one example to you all. Given that here Okay, right. What is the need of sending passcode here, Nana? Already someone put the Zoom link straight away. If you press the Zoom link, you will get the invitation straight away. Okay, right, no problem. Given that the acceleration, uniform acceleration. Good afternoon, Nana. The acceleration is 10 meter per second square. Okay. So how to solve this question? Okay, we will see. Yeah, anybody here will give the answer for this question or not? Okay, you can read the question, try to solve it, Nana, if you are getting the idea. Otherwise, wait, I will explain. 20 meters per second. Okay, very good. Yes. Okay. Here, have you got the 20 meters per second from this one, Nana? Yeah, 20 meters per second. I think it is correct only. Have you got? A is equals to V by T. Is it V by T or V minus U by T? Or this is 10 into 2, okay. Means we used which formula, Nana? Sharmi Priya? Yeah. I think A is equals to V minus U by T. Right. Okay. This equation I think you got in your lower standards in 9th class. Am I right? Yes, this is 9th class equation. Yeah, good. Not velocity by time, Nana. Acceleration is change in velocity divided by time. Yes, correct. Not velocity by time. Very good. So here the concept what Manikanta is saying there for acceleration, keep in mind again, when a body is moving with uniform acceleration, then acceleration A equals to formula change in velocity, that is change of velocity, divided by time. Okay, so change of velocity means if the initial velocity is u, good afternoon, initial velocity is u, and the final velocity is v, then the acceleration, yes, then the acceleration A is equals to your formula change in velocity final minus initial v minus u divided by t. Okay, I think actually I should not explain this thing. Why? Because you know in your 9th class, just I am trying to recollect that formula, Nana. This one. Yes, correct. Okay. Just now only, Nana. Just now only. This is the first one I am trying to explain. Yes. Okay. Am I right, Nana? From this formula? Yes. Now you come to your problem here. What is the solution for this? Okay. Given that body started from rest. Started from rest means anywhere what you take, Nana, started from rest. If in any problem started from rest, suppose given what you take, who is zero? Who U is 0, right? Correct. Okay, initial velocity is 0. Correct, correct. So here straight away I'm coming to from the concept, a body started from rest. Initial velocity is equals to 0. And here he is asking find the velocity of the body. Means final velocity is equals to how much? And here after 2 seconds he is asking. So t is given as 2 seconds. And given that acceleration is equals to 10 meter per second square. Okay. So using the formula, A is equals to, what is the formula here from the concept? A is equals to V minus U by T. You can straight away, you can use this formula, or whatever you learnt in 9th class, by taking cross multiplication, another formula you will get, that is AT is equals to V minus U. Taking U to the other hand, you will get V is equals to, by taking minus U to the other hand, U plus AT. Okay. I think you learned this one as the equation of motion. Am I right now in 9th class? First equation of motion. Yes, correct. First equation of motion. V is equals to U plus AT. Right? So using this equation straight away, yes, correct. Straight away you can find out what is the final velocity after a certain time, 2 seconds, substituting all the values. V is equals to U is given as 0. And here A is acceleration 10 and time is 2. 10 into 2, that is equals to 20. 20 plus 0, 21. 20 meters per second. Okay, very good. Right. So first equation of motion here we discussed. Right. And here I am going to write what are the equations of motion. Equations of motion here. Okay. Those equations of motion I am writing here. What? When a body is moving with uniform acceleration. I think you recognize it or not. Everything, whatever I am discussing here is related to uniform acceleration, means acceleration is constant. Okay, uniform acceleration. Okay, don't apply these equations when a body is moving with uniform velocity. This is for uniform acceleration. That's why here I am underlining that one. Uniform acceleration. Yes, yes. Uniform acceleration, not uniform velocity. Okay, and non-uniform acceleration. Only for uniform acceleration. Right? When a body is moving with uniform acceleration, then the equations of motion. Equations of motion. Okay. One equation here we tried to recollect, that is from 9th class. V is equals to U plus AT, one equation. Or the same thing is A is equals to V minus U by T. From this equation only we got V is equals to U plus A. Right? Okay, very good. Now don't take the snapshot, Nana. Why? Because still we have to write two more equations here. After taking those two equations, I will give a chance to take the snapshot. Okay? Okay. Now, can I move to next page, Nana? And now itself, don't take the snapshot now. Okay, I will give the chance. Right. Okay. Now, here try to recollect the other equations of motion also, what you know in the lower standards. Okay. Here, to recollect those things, just I am giving one example, one more. Example 2. Look at here. A body is started with an initial velocity say some 2 meters per second, means it is not started from rest. Okay. And accelerated uniformly with say some 4 meter per second square. Okay. And covered a displacement not given in a time of say 2 seconds. Find the displacement. Just one example I completed, Nana. This is the second example. Okay, that is from 9th class. I tried to recollect one formula, that is V is equals to U plus AT. From that, here I gave one example, Nana, right? And please stop your videos, okay, here. And then I am going to the second example. Okay, this is the first example related to the equation V is equals to U plus AT. Okay, right, good. And here, second one, Nana, I am going. This is the second one. Okay, right. Find the displacement. Okay, here anyone recollected the concept, Nana, for this question? Got any idea for this question? 20 meters, Manikantha. 20. Yes, I think you are right. What you recollected, Nana, from 9th class? Mr. Manikantha? Yeah, correct. 20 meters, Nana, not meter per second. Displacement, kada? It is 20 meters. Yeah, correct only. 20 meters. Yeah. What the formula you recollected for this? Very good. S is equals to ut plus half at square. Yes, correct. Yes, Tanisha, correct. So here the concept related to this question, I think all of you know this one in your lower standards. 9th class, S is equal to ut plus half at square. All of you know this one, Nana? All of you know this equation? S is equals to ut. Right. Good. Right. So here, when a body is moving with, yeah, we remember. Very good. Very good. Then apply that equation, Anna. We will get the answer. When a body is moving with uniform acceleration. Okay. Uniform acceleration. Once again, I am telling here uniform acceleration only. Uniform acceleration. The displacement. Okay. Displacement of the body in a given time. In a given time is the concept formula what you wrote there. S is equals to here what we write, Nana? S is equals to ut plus half at square. Okay, this is the concept related to the problem. Okay, that one we have to use here. I think no need to explain. You remember? Yeah, good. Then I'm coming back to here the example solution here. Given information, first we write initial velocity. I think all of you know initial velocity is represented with the letter U. U is equals to 2 meters per second given, and accelerated uniformly. Yes, uniform acceleration. Our required condition we got here with 4 meter per second square. So acceleration is 4 meter per second square, and covered some displacement not given, but in a time, some time is given. T is equals to 2 seconds. And here the displacement he is asking. Okay, by seeing this only, we can find out the interlinked concept. Oh, it is a relation between SUAT. SUAT. This is the equation. So immediately we recollect that formula, S is equals to ut plus half at square. Okay, from this we will get S is equals to u 2t 2 plus half a 4 t square. 2 square is 4. So if you cancel here 2 times, this is 4 plus that is Nana, is the answer 20? I think it is 12. Is it 20 or 12? I think, yeah. Yeah, I think where you did the mistake, I don't know. 12 only. Yes. Values, I think somewhere you 4 plus 8 is 12. Right. There, I think you did the mistake. Yeah, 4 twos are, this is 8. Maybe, yeah. Maybe they did not consider half day. Okay, but they put the equation correctly only. S is equal to ut plus half it square only. They put. Yeah, correct. 4 twos, 8. That is 4 plus 8, that is equals to 12 meters. Okay, good. So can I copy this equation in the previous page on a second equation of motion? Yes. So here I am writing in the first page, second equation of motion. S is equals to ut plus half at square. What we recollected again from lower standards. Yes. Before starting the third one, anyone remembered the third equation of motion, Anna? Anyone remembered? Try to recollect. Third equation of motion. Yes, Lakshmi Gayatri. Okay, yes. Tanisha, yeah. Akhil, yeah, correct. V square minus u square is equals to 2as, or v square equals to u square plus 2as. Yes, correct one. So I think few remembered here. So can I straight away write that equation here in the as the third equation, Nana? Why? Because you remembered it. Okay. Right. This is here third one. V square, yes, v square minus u square is equals to 2a, yes. Okay, good. Now I am coming to there. Okay, try to apply this equation, Nana, in the example 3. Okay, here example 3. What? A body is started from rest. Okay, I think here u is given as 0, initial velocity, started from rest, and accelerated uniformly as usual. Uniformly. Okay, with some 4 meters per second square. Okay, with some acceleration given here. And okay, it covers a displacement of displacement of, better we say, what, a half meter. Okay, displacement of half meter in a given time. Not time is not given, in a given time. Find the final velocity. Okay, find the final velocity. Is it 4 or 2? I think it is correct. 2 meters per second, maybe. Okay, I think all of you applied the equation v square minus u square is equal to as. Yeah, correct. Right. So that concept here I'm going to write for this example. Yeah, I think all of you write. Okay, for a body moving with uniform acceleration. Okay, uniform acceleration. The velocity of a body after a certain displacement, after acquiring some displacement, certain displacement. Acquiring certain displacement is related as equation. We write here v square minus u square is equals to 2as. Okay, right. This is one relation that we are taking here. I think from that equation only you are trying to get the answer for this question. Okay, so I think all of you got here, almost majority of the students got the answer 2 meters per second. So I think it is very easy, cakewalk, we can solve here. V square minus u square is equals to 2as. Not even taking the data here. Why? Because all of you understood there. Initial velocity from this equation, I'm going to substitute. Yes. Need not to explain. Very good. Just I'm going to write the values, Nana. Just that's it. I won't explain. Okay. 2a is 4 and s is half. Okay, just I'm going to write here v is equals to 2 meters per second. Yes, what you explained, what you said is correct. Need not to explain. It is very simple. V is equals to 2 meters per second. All of you got it. Okay, good. Now it is the time to move properly and smartly. Here, look at the question, Anna. Now, right? I'm moving to the next page here. The example, I think, is fourth. Okay, example 4. Look at the question. The initial velocity of a body is take some 4 meters per second. Okay. Yeah. After completing all the equation, then I will give a chance to take the snapshot of the first page and second page. Okay, nothing to worry. Here, the initial velocity of a body is given as 4 meters per second. Okay. And it is accelerated uniformly as usual. Yes, it is accelerated uniformly with, okay, take some 2 meters per second square. Right? Now I am asking a question, that is, find the displacement covered in third second. Do you know this model, Nana? Do you know this model? Finding out the displacement in a particular second. Forgot. Okay. Anyone remembered? don't say answer, Nana. Did you remember the formula? Okay, no problem. Mr. Who gave the answer? Amok. Amok remembered the formula? No. Yeah. Amok gave the answer, just to put the question mark there. It means I think he also has some doubt on his answer. U plus A by 2 into, yeah, you are right, Nana. That is the formula, A by 2 into 2n minus 1. So many forgot here. So I try to explain that one. Okay. You want the explanation on all of you? Do you want the explanation? Yes, yes, yes. Okay, right, good. Then come to here, Nana. Simple. Suppose if I explain like this, I think you can understand. What? Suppose if I take here, like a body is moving on the straight line. Okay. Suppose started from rest here. Okay. Take u is equals to 0. And moving with some constant acceleration. Okay. Say some 2 meters per second square. Right. Or else whatever the value here given to, luckily that is 2 meters per second, but initial velocity is 4. So better I take here the initial velocity as 4 nano. Initial velocity is equals to 4 meters per second accelerated. And he is asking what is the distance covered in third second. Okay, no problem. If I ask what is the distance covered in total 3 seconds, okay, means from here to there, total time is equals to 3 seconds. That is suppose A to C. Okay, time is 3 seconds. How to find the displacement AC here, Nana? I think this one you know. In total 3 seconds. Using, I think, second formula. Second equation of motion. Am I right? Yes, correct. Okay, so A to C, the displacement using displacement is obtained using S is equals to ut plus half at square. Okay, in 3 seconds, I am representing with S3, Nana. In 3 seconds, S in complete 3 seconds is equals to U. I am going to substitute for T is 3 seconds plus half A. A is 2. T square is 9. Okay, so I will get here 2 cancel, Nana. This is 4 3s are 12. 12 plus 9, that is 21 meters. Right, 21 meters. Okay, but I think this is not the answer. It is the total distance traveled in 3 seconds. Okay, if I ask anyone here, Are Nana, I started from with some velocity, moving uniform acceleration. In 2 seconds, I traveled 10 meters, Nana. And in complete 3 seconds, I traveled, yeah, in 3 seconds, I traveled here, complete distance, say some 12 meters, right? Okay, then who is this? This is the distance from, means what I am saying, A to B is the distance traveled in 2 seconds. A to C is the distance traveled in 3 seconds. Okay, then who is this BC? Who is this BC? Did you recognize? This is the distance traveled in 2 seconds. Okay. And yeah, Amog raised, I think he knows the answer. Will you explain, Nana Amog? Ah, right. So I can't. Okay, right. Lakshmi Gayatri told it is the distance traveled in. Look at Nana. Look at. Is it third second? Yes. Lakshmi Gayatri told correct, Nana. Why? Because yes. Why? Because here 2 seconds completed from B to C. When you come to C, only third second is completed. So B to C means 2 completed, 3 not yet came to here in between. So this is actually the distance between in between 2 and 3. In between 2 and 3, this is called as the distance traveled in third second. Did you follow this concept, everyone, Nana? All of you followed this one? Yes, good. So here look at what I have to take to find out BC. Can I say BC is equals to, sir, total is 12, sir. Till here, this is a 10, sir. So why don't you write BC is equals to AC minus AB? That is what 12 minus 10. That is what 2 meters. Is it correct? Yes, 2 meters, correct. So here, how you calculated the distance traveled in third second in my example? Identify the method. What you did here, you calculated the total distance traveled in 3 seconds, that is 12, and then you subtracted the distance traveled in less 1 seconds, that is 2 seconds. Okay, that is 10, and you set the answer. This is the distance traveled in third second. Okay, means in a simpler manner, what can you say? Distance traveled in third second means you have to take S3 in complete 3 seconds minus S. Yeah. That is one example, Nana. I am not saying that that is 12. Just I said this is 12 in Satvik, Nana. Every time you are trying to open your video. Okay. Here, this is what I said, Mr. Rafan Ahmad. Just I gave one example. In 3 seconds, I assumed it as 12, and in 2 seconds, I assumed it as 10. Okay. Then I asked you what is the distance traveled in third second. So all of you understood my example here, Nana? All of you understood? Yes. If you understand this one concept here, already I calculated S3. Okay, right. I am not, sorry. Okay, Nana, okay. Here I calculated already S3. Next, what I have to calculate there? Okay, no problem. What I have to calculate next there? I already calculated S3 now. Next, what I have to calculate? According to my example. Yes, 2. Yes, correct. Means distance traveled in 2 seconds. Okay? Right. So distance traveled in 2 seconds. Now I am going to write here. Okay, distance traveled in 2 seconds. Okay, I'm going to calculate. That implies the displacement and the displacement covered in 2 seconds is S2 is equals to, again using the formula ut plus half at square. Okay, that is equals to u, again 4 into t. T is how much? 2 seconds this time, in 2 seconds. So ut plus half, a is 2, a is given as 2 nana, into t square, that is 2 seconds, 2 square. So again 2 cancel. This is 4 2s are 8. 8 plus 2 square is 4. 8 plus 4, that is equals to 12. Yeah, good. 12 meters. Okay. So here, according to my example, what I said, that implies, correct only, ma'am. That implies distance or displacement covered in third second is equals to, okay, distance covered in third second is equals to, what is that, Nana? S3 minus S2. That is equals to, here 21 minus 12, that is equals to 9 meters. What Amok posted, I think it is correct. 9 meters. So all of you understood this one, Nana? Third is 9. Yes. Okay, right. Good. Then try to here derive the formula for this one, Nana. Okay, right? According to the formula, we try to solve this problem and we try to show that it is also 9 meters. Okay, so here I am going to write the concept related to it. Here, anyone understood one underlying thing here? If I ask the distance traveled in third second, logically try to catch the point or date. Oh, if it is the third second, this is S3 minus S2. Means one less here. Yeah, good. If I ask it is a 10th second, Nana, then what you do here? Okay. Finally, you are saying, right. Yes, 10 minus S9. Very good. So here, this one, what Mr. Akhil Gollapudi wrote, in the same way, distance traveled in nth second means I have to write it as Sn minus Sn minus 1. Yeah, correct. Correct. So that concept here I am going to write. Right? The distance traveled. Okay, Nana, I am writing here. The distance traveled in nth second is Sn equals to Snth equals to, here better we write neatly, Snth equals to Sn minus Sn minus 1, what we understood from this example. Okay, good. Then Sn means, again using the formula, distance traveled in n seconds means using this formula, Nana. Okay, Sn I write here, that implies Sn equals to Sn u into t, t is n, okay, plus half a t square, t is n square, okay, minus big bracket here Sn minus 1. That is also, again you applied same formula ut plus half at square, that is u time n minus 1, Nana. So a u into t n minus 1 plus half a into t square n minus 1 whole square. Okay, just to try to expand, Nana, you will get the answer. So this is equals to un plus half an square and half an square minus, here I am trying to expand, u into n, un means straight away I can cancel these two terms. Okay, minus un, and here minus of minus plus u. Are you able to follow my expansion, Nana? Or any confusion in the middle? Able to follow? Yes, okay, good, good, good. Then here, yeah, right. Minus, here plus minus minus, Nana. Minus half a into, I am expanding this term, Nana. A minus b whole square. A minus b whole square means a square, that is n square. This is minus 2n minus 1, that is plus 1 square, that is 1. Okay, I think you know this expansion, no need to explain. Okay, so this is equals to what you are getting finally, half a n square here plus u, and try to expand this one, Nana. Minus half a n square. So straight away you can cancel these two terms, half a n square. Yeah. What, Nana, where you are getting the problem? Just the distance traveled in, like in third second, what you did, Nana? Yes, third second means yes, 3 minus yes, 1 less, Nana. 3 minus 1, that is 2. In the same way, if I ask in place of third, if I ask nth second, then what you supposed to write here? Yeah. We are finding out the formula. That's it. Yeah. Why? Because you said that this is just, you understood this example, Nana? Ishan? Did you understand this example? Ishan? Then same thing I am trying to derive the formula, Nana. That's it. For third second, we already got the answer, but we did in a lengthy procedure, Nana. To avoid this lengthy procedure, trying to extract one formula. That's it. Is it clear? Not multiple. Subtract. Correct. Yeah. What, Ishan? Okay. Right. Good. So here, this is minus half a n square, and minus of minus, this is plus. Okay. Half. Oh, first I have to erase this part. Okay, right. Plus half a n square over nana, minus of minus plus half a into 2n minus half a into 1. Okay, just expanded that term. Okay, now look at what you got there. This is equals to u. Okay, and here and there you observe half a again common. Okay, plus half a into, observe there, what is there? 2n minus 1. This one only what they said, u plus, if I take 2 into u plus a into n minus half. Okay. So this is the final equation to find out the distance traveled in, not in n seconds, Nana, nth second, one particular second. Like here what we require, third second, like a 10th second. Okay. Right. Now with that formula, we will get very easily, Nana, here. Yes. Nth. Yeah. Correct only. Okay, Nana. So from this, I am going to write here. What will be the answer for this question? Solution. Okay. I'm not using this lengthy procedure, Nana. Okay. Just I'm writing here the distance traveled in third second, he said. Third. So nth second is already given. That is the third. Okay. And here given initial velocity u4. Sorry. meters per second. Acceleration is given as 2 meter per second, sir. Ah, very good, Nana. Very good. 2 meter per second square. Just substitute the values. You will get the answer. That's it. Maybe. Okay. Yes, nth is equals to here u. U is 4. Okay. First, better I write the equation. U plus half a into 2n minus 1. That is equals to u is 4 plus half a is 2 bracket of 2 into nth second, that is 3 minus 1. Okay, this is 2 cancel, Nana. This is equals to 4 plus 2 3s are 6. 6 minus 1, 5. Yeah, good, good, good. Now you, yeah. Now you came onto the track. Very good, Ishan, Nana. 5 plus 4, that is equals to 9 meters. Very good. This is the distance traveled in nth second. Now is it clear, Nana? Yes. And this is the original procedure. Which one what I derived here. Okay. But in exam, we never try to solve like this. We try to solve using the short method. Okay. So this method is the original procedure now. What we got here. Yes. Charmi Priya, do you have any doubt, Nana? Yes, do you want to ask anything? Yes, now you can ask if you have any doubt. Charmi Priya? No doubts. Here, Charmi Priya raised the hand. Any doubt? Okay, okay, no problem. Then, right. So here, yeah, here, okay, Nana. Here, this is what, Nana? Original method, original procedure. Okay, right. Now we can add this equation in the first page. Can I go to first page, Nana? And add there. Yeah, I'm going to move into first page. No, no, no. No one is opening the mic here, I think. This is the distance traveled in the nth second. Yes, n. Okay, sorry. Here I write. Yes, n is equals to distance traveled in nth second equals to u plus what I got, a by 2 into 2n minus. Sir, by using the formula, we need to solve the problem. Solve the problem means no need to solve like nth second means in n seconds to n minus seconds and subtracting. That procedure we never try to solve now. I will check now. No one I think opening. Why? Because I am not getting any disturbance in the middle. If they open, I will get some disturbance. Okay. Even though I will check now, Ishan. Right now you can take the snapshots, Nana, if you want to take. This is the first page. This is first page. Is it completed? Took the snapshot, Nana? Yes, I'm moving to the next page. Done, sir. Okay, right. Okay. This is the second page. Do you want this second page? Done, Nana? Right, good. I'm moving to third page. Okay. And this is the third page. Finished. Okay, right. Can I move to fourth page? Yes. Okay. Now here come to the page 4. Here we will see whether you get the idea or not in this example. Okay, this is example 5. Okay, see how many will get the idea for this question. The okay, the initial velocity is given as 10 meters per second for a body moving with uniform acceleration. Okay, but keep in mind that acceleration is not given. Okay, right, uniform acceleration. It acquires a velocity of 24, or better we take some, oh no problem, 24 meters per second in 6 seconds. Okay, find the displacement. Okay, once again I am repeating the question, Nana. Here, what are the informations given for you? Initial velocity given, Nana, means u is given. Okay, to get some clarity, I am writing here. U is given, but acceleration is not given. Okay, and here final velocity is given 24, that is given, and time is given. Okay, I will check, Nana. 14/6 acceleration. Okay, right. Okay, and he is asking what is the displacement, right? Yeah, acceleration is 14/6, correct only. Then displacement means what you are saying? Finally answer. 102 meters, Lakshmi Gayatri. Okay, Gayatri is saying that 102 meters. Okay, we will check. Any others? Manikanta got 65. Okay. Afanama saying that it is 78. Charmi Priya saying 40. 40, I think absolutely not correctly. Why? Because u into t itself I am getting 60. So I think 40 is not correct answer. Sai Sham is telling it is 102. Oh, what Lakshmi Gayatri told, same answer. Alcha MS also saying 102. Okay, 6 6 here 2 7s 42. I think 102 is correct. Okay, I think all of you did. Yeah, Ishan, correct only, Nana. Lakshmi Satvika 102. Right. Deepali 102. Right, no problem. I think all of you first calculated the acceleration and then calculated the displacement. Am I right? Yeah, 102 correct only, Nana. But all of you calculated the acceleration first. Yes. So, but here, look at my method. Yes, sir. Yes. Correct. I am saying my method, Nana, here. I am not interested to calculate the acceleration, Nana. Without acceleration, I am going to find out. Without finding out A is equal to, you told something like 14/6. Without A, I am going to find out the displacement. Look at my method. Once you check here, given that according to the information there, u is equals to given as 10 meters per second, acceleration not given, final velocity is given as 24 meters per second, time is given as 6 seconds, and he is asking what is the displacement. Just look at my method, Nana. Here acceleration is not there, so I am going to avoid the acceleration. Okay, how, sir? Look at my solution. Better I go with y, because vu yes given. So I am going with the third equation, Nana. V square minus u square is equals to 2as. Okay. Then I recollected the mathematics here. A square minus b square can be written as a plus b into a minus b. So this v square minus u square I am writing like v plus u into v minus u. That is equals to 2 into acceleration into displacement. Acceleration, time is given. So acceleration formula, better I try to substitute v minus u by t. All of you know this one. Okay. Then the advantage is, yes. Is my voice breaking? I know, I think no. Even though no problem. This is almost last one. Okay. So, yeah. V minus u cancel, Nana. So I am getting here v plus u is equals to shortcut formula 2s by t. Okay, without acceleration. If suppose in a problem acceleration is not given, then we go with this formula. What there, that implies v plus u is equals to 2s by t. Okay, this one straight away I'm going to use here in this problem. Okay, why? Because v is given for me, u is given for me, yes, he is asking, time is given. Okay, so straight away I go with this formula, right? That implies I write here from this formula, Nana, v is 24, u is 10 is equals to 2, s is not given, by t is equals to 6. Look at here. That implies 24 plus 10 is 34 is equals to 2s by 6. Then 2 1s are 2 3s are cross multiplication. Here 3 4s are 12, 3 3s are 9 plus 1 10, 102 meters here without finding out what the acceleration I calculated. Will you accept my method here, Nana? Yes, good. So can I add, can you take, this is one extra equation for us? Okay, so can I write it as the fifth equation of motion? Yes. So this is 4 equations I wrote there in the first page, Nana. So I'm taking it as a fifth equation of motion. Okay, 1 2 3 4 already there in first page, so better you take it as fifth. Fifth equation of motion. New formula now, new formula. Okay, that anywhere you can use if acceleration is not given. No need to find out the acceleration, finding out and then again substituting. That is a lengthy procedure. So here just using this formula in 2 steps I got the answer. That's why better we remember this fifth equation. What is that? Am I right? Yeah, okay. So here today we learned few things related to a body moving with uniform acceleration. Okay, so can I stop the class, Nana, now? Okay, can I stop sharing? Yes. Did you take this 4th page snapshot? Actually 4, Nana. These are for our sake we are taking the extra equations. Actually 4 only. Okay, right. Bye, Nana. Bye, everyone. Have a happy Sunday tomorrow.